Okay, in this video I wanted to finish up section 9.1. We're talking about confidence intervals, about the population proportion, and we've looked at a couple of problems and doing some things on the calculator. Now the last thing that I want us to check out here is the sample size that would be needed for estimating a population proportion. So the sample size required to obtain a 1 minus alpha times 100% confidence interval for the population proportion with the margin of error E is given by this formula that you see for N. Okay, P hat is a prior estimate of P. If a prior estimate is not available, then here would be the formula that you're using instead. Okay, prior estimate simply means that, if somebody has already done the same problem before you, like, you can use their information in this formula here. Okay. Otherwise, if you're doing it for the first time, or if you choose not to use their information, here would be the alternate formula. Okay, now there's a note below that, two notes actually. The margin of error should always be expressed as a decimal when using either of the two formulas. Okay, and there's another note: always round n up to the next integer if n is not already an integer. The bigger the sample, the better, so increasing the sample size is a good thing, not a bad thing. All right, let's take a look at problem 5, where it says that a sociologist wishes to conduct a poll to estimate the percentage of Americans who favor affirmative action programs for women and minorities for admission to colleges and universities. Part A. What sample size should be obtained if she wants the estimate to be within 4 percentage points with a 90% confidence level if she uses a 2013 estimate of 67% obtained from a Gallup Youth survey? All right. Like, how big should the sample size be to have all of this work out? Like, she's got all this planned ahead of time, and what size sample should she use? We want to make sure that the sample is going to fit all the information here. So now she's using a prior estimate. So I want to make sure I'm using this formula here when I do the calculation. Let's see. Alpha would be 0.1, since 1 minus 0.1 is 0.9, and 0.9 times 100% is the 90% level that she is desiring here. Okay, now in the formula, alpha divided by 2, 0.1 divided by 2 would be 0.05. P hat is the prior estimate, so Gallup did the same thing in 2013. She's going to use that information. 67% said that they were in favor of affirmative action programs, and so the P hat value would be 0.67. 1 minus 0.67 would be 0.33. Okay, Z sub 0.05 is a z-score that I'll need to look up. I'm going to do that on the next line. And then she also wants to be within 4 percentage points on either side of the point estimate, or the margin of error has to be 4 percentage points. E, therefore, would be 0.04. Make sure that the margin of error is always expressed as a decimal, it said. All right, so our information is all plugged in here, and I got to get the z-score. Now, we've seen this notation before. The subscript is indicating area to the right. We saw this in Chapter 7. Table only gives area to the left. Okay, and I'll be using the table here to look up the z-score. But so if the area to the right is 0.05, the area to the left would be 0.95. So I'll be using this chart in reverse to find my z-score. I'm looking for 0.95. More specifically, that'd be 0.9500. Think of that as a 4-digit decimal because that's an area. We don't see that number. Many times when we're using the chart backwards, the number is not listed. And we have two numbers that are the same distance away from 0.9500. They're 0.9495 and 0.9505. It wouldn't be right to take one z-score over the other. Like, I wouldn't want to take 1.64 or 1.65. So we've seen this before. We're going to go right in the middle of the two z-scores there, and we're going to call it 1.645. Okay, and so that's how I'm getting the numerator. Be sure that you're squaring this information. Now everything is plugged in. Okay, and now I would go to the calculator and type in 1.645 divided by 0.04 squared times 0.67 times 0.33, and I was getting roughly 373.9. Always round n up to the next integer if n is not already an integer. So in order to make everything work out here, she's going to want at least 374 people participating in the sample. Okay, now anything bigger than that would be okay. You know, if she had 900 people participating, then great. You know, that's more than enough. Okay, but 374 would be the the smallest possible sample size in order for everything to work out here. That would be what she wants happening ahead of time. All right, part B, what sample size should be obtained if she wants the estimate to be within 4 percentage points with a 90% confidence level if she does not use any prior estimates? Well, if she doesn't use this information from Gallup, maybe she doesn't know about it or she just chooses not to use it, then she's got to use this other formula here. And the only adjustment is instead of p hat times 1 minus p hat, you're just going to call that multiplier 0.25. So the only change here is instead of 0.67 times 0.33, I'm just going to have that be 0.25. Everything else is going to be exactly the same as it was in part A. We got our z-score, and so if you take 1.645 divided by 4 squared and then multiply by 0.25, I'm getting 422.8. So you're going to call it 423 then. For the sample size. Okay. Now, the sample size is going to be more than what it was in part A. In general, that's going to happen if you're not using any prior information. Like prior information is a good thing. If somebody's already done this, like that's a good thing, and you won't need to have as many participate then in the study if you're using that prior information. Otherwise, you're going to need a bigger sample to have everything work out. Okay, we'll look at problem 6 is the last problem in section 9.1. So we'll do that. It says in 2013, a national survey conducted by the CDC, 58% of high school seniors polled said that they had texted or emailed while driving during the previous month. And suppose that the margin of error in the poll was 2.5%, and the estimate was made with a 95% confidence level. At least how many seniors were, how many high school seniors were surveyed? Okay, so again, this is a real study by the CDC. The CDC, of course, a big research organization. Okay, and now they're not telling us how many high school seniors were surveyed, but we can figure that out by the other information that has been given here. So we need to know the sample size, or at least how many, n, and let's see, from what was reported, so 58% of the high school seniors polled said that they had texted or emailed while driving in the previous month. So p hat would be 0.58, 1 minus p hat would be 0.42. The CDC reported all this information with a 95% confidence level. Therefore, alpha is 0.05. Alpha divided by 2, 0.05 divided by 2 would be 0.025. And that's going to be the subscript on the z-score that I'm going to look up on the next line. The margin of error was 2.5%. So in the denominator, you're going to want to convert that percent to a decimal, and that's where I'm getting this 0.025. Okay, so my information is all plugged in. I just got to, find n now. Let's get the z-score. So again, the subscript is indicating area to the right. Table only gives area to the left. So if you take 1 minus 0.025, you'll get 0.975. And that is the number that we want to be looking up here in the chart, 0.975, and it's actually listed. Okay, this is a rare time where the number that we're looking for is actually there. This usually doesn't happen, so if you match up the row and column, 1.96 would be the z-score that we need here in the formula. So that number is going to go in the numerator, and then we can go to the calculator and type this in. 1.96 divided by 0.025 squared times 0.58 times 0.42 is roughly 1,497.3. You're going to round up and call it 1,498 high school seniors were surveyed. At least that many. Now we're not going to know the actual number, okay, but at least 1,498 participated in order for all this information to have happened in the study. Okay, we are now done with section 9.1.